This is the new multi-mission General Dynamics Model 48 Charger, the first airplane designed specifically for brush fire warfare. As you watch this film, the Charger flight test program is continuing at General Dynamics Convair Division in San Diego, California, so that the Charger can demonstrate its predicted performance throughout the entire flight envelope. Soon, the Charger will be a flight test proven product. Production versions will be available for light-armed reconnaissance, counterinsurgency operations, transport, surveillance, and other support roles. Construction of the airplane started only 8 months ago, but its development dates back to 1962. An important part of the overall Charger development program was this 1/6 scale model, which was tested in the Convair wind tunnel. More than 900 separate test runs were made to verify performance and stability and control characteristics. The Charger also was configured for amphibious operations so that the airplane could operate from forward area lakes and rivers. Convair built this 1/7 scale model to determine hydrodynamic characteristics of the float system. Test runs were made in the Convair towing basin at high and low speeds and in both rough and calm water, demonstrating the stability and handling qualities of the amphibious version. In March 1964, General Dynamics formally proposed its Model 48 Charger to the Bureau of Naval Weapons. At the same time, the company began building a prototype aircraft to demonstrate the performance guaranteed in its proposal. In designing the Charger, Convair was as much concerned with simplicity as with performance. The rectangular plan form of the wing and tail, for example, meant that these structures could be produced in sections of constant size from one stamping. This eliminated costly tooling, speeding production. Charger was completed in just a little more than 6 months. On September 29th, rollout ceremonies were held at Convair's San Diego plant. The light weight of the Charger was emphasized when 2 men pulled the airplane into the final viewing position. Actual weight of the airplane, minus fuel and payload, is 4,450 pounds. This is 7 pounds lighter than the weight guaranteed to the Navy. Although the Charger is technically a prototype, the airplane was built to production standards. Consequently, no major redesign will be necessary for volume production. Later, the Charger's general configuration and operating characteristics were described by James Fink, Convair's manager of close support and surveillance aircraft.
The Model 48 is small in size. Its 27.5-foot wingspan enables it to operate from narrow, confined areas. The aircraft is powered by 2 650 horsepower turboprop engines. These engines drive 2 3-bladed, 9-foot diameter counter-rotating propellers. The landing gear of this aircraft has been designed for a 20-foot per second rate of sink. It's a conventional tricycle landing gear. The cockpit arrangement provides for a crew of 2, a pilot and observer. The aircraft's construction is conventional aluminum monocoque. The constant chord, wing, and horizontal tail allow us to have 1 die stamping. The booms, after the production break, including the vertical tail and rudder, the fuel tanks, the flap segments, the landing gear are typical examples of interchangeability left and right. This provides for a 48% commonality of parts, compared with 10 to 12% in today's conventional aircraft. This not only reduces logistic requirements in the field, but results in a low initial cost for the aircraft. All of the flight controls of the aircraft are manually operated. The large horizontal tail system is a unique system which is an aerodynamically tab-driven variable cambered surface. The vertical tails support rudders, which are the directional flight control systems. The lateral system is another unique system which combines circular arc spoilers and ailerons on the outboard span. The landing gear and flap systems are hydraulically operated. The flap setting for takeoff is 10 degrees. For the landing configuration, the flaps turn to a complete 90 degrees. The full span flaps covering the wing from tip to tip and the inboard Kruger flap provide the high lift required for this aircraft to operate from short takeoff and landing fields.
During the time between rollout and first flight, the Charger underwent an intensive series of ground tests. One such test involved weighing and fueling the airplane to determine its weights empty and fully fueled, and to calibrate fuel gauges. Easy access to the engines simplified adjustments that were necessary during testing. The Charger is constructed for maximum accessibility and ease of maintenance. An engine, for example, can be removed in 15 minutes by just 2 men using ropes if a mechanical hoist is not available. A few days before actual flight, static engine runs were made, and the Charger was taxied at various speeds to check engine response, nose wheel steering, brakes, and other systems. On November 25th, last-minute preparations were being made for the Charger's maiden flight. When the airplane was ready, veteran test pilot John Knabel climbed into the cockpit, made his pre-flight checkout, and started the engines. The observer space behind him held instrumentation equipment that would monitor aircraft performance and transmit data to a ground station. During the taxi run to the head of the field, the pilot made final communication checks with the tower and ground stations. Then the Charger headed down the runway and was airborne in a matter of seconds. It is designed to take off with a ground run of only 225 feet and clear a 50-foot obstacle in less than 500 feet. After takeoff, the airplane banked to the southwest over the entrance to San Diego Bay, then banked again and headed toward its test area near the international border. During this flight, the Charger was necessarily limited in speed and range. But when operational, it will be capable of speeds in excess of 300 miles per hour, and its 3,000-mile ferry range will allow it to fly from San Diego to Hawaii without refueling. Consequently, the airplane can be easily deployed to any trouble spot in the world. After accomplishing its flight objectives, the Charger ended its first flight, landing at North Island Naval Air Station. This marked the beginning of a 100-hour flight test program to further demonstrate performance and handling characteristics. A few months ago, the Charger was just a paper airplane, the result of thousands of hours of engineering design and development. Now, it is a real airplane, proven in flight, an airplane ready for volume production. It is a bird in hand. This is the new multi-mission General Dynamics Model 48 Charger, the first airplane designed specifically for brush fire warfare. As you watch this film, the Charger flight test program is continuing at General Dynamics Convair Division in San Diego, California, so that the Charger can demonstrate its predicted performance.